one key skill that we need to be able to perfect when it comes to mathematics, especially at this level that we're working at, is proofs. And there's a variety of different types of proof that you're able to complete and that you're able to do. One type of proof that we're going to discuss here is what's called proof by counterexample. So this one here essentially is, can you prove me wrong? Give me some sort of an example. Now we have to understand what this relates to. So one thing we have to define is the term conjecture. Now an easy way to think about this is it's just simply a statement that someone thinks is true. So for example, a fish is an animal. That's a statement, I believe it's true. However, quite often these can be based on incomplete or incorrect information. An example of this might be something like, any four-sided shape with right-angled corners is a square. Well, we know this isn't true because I can give you an example where a shape with four sides with right angles in the corners is actually a rectangle. So we know that that conjecture is false. Now, generally, what we can do is we can take these conjectures and the way that they're worded and provide a counterexample. So what this means is some sort of example that disproves the information. If we can disprove it using this counterexample, then we show that it's not true and it's false. Proving it's false then gives us our proof and our counterexample that it doesn't work. Now, many of these can be found in a variety of ways. We can find counterexamples using a variety of techniques. These can include things like trial and error, using different sets of numbers, remembering relationships between positive and negative numbers, and using just our general numeracy at hand. So for example, if you've got a square number, remember a negative square always gives you a positive. That's a property of numbers that could come important and could be used effectively to prove these. Now, I'm going to show you a couple of examples of what I mean by this and how to come up with a counterexample based on a conjecture that is given to you so that we can prove it's false. So let's consider the statement, x squared plus 1 is odd for all x. I want to find a counterexample to disprove this conjecture. Now what we have to do with this is trial and error. This sort of statement here, what we can do is approach it and say, right, I'm going to try a few values for x. If those values give me something that is not odd, i.e. is an even number, then we've given ourselves a counterexample and it disproves this conjecture. Now if we were to take a value of x, let's see we were to take x equals to 2. Now if I take the value x equal to 2 and I plug it into that statement, what I'm going to say is I'm then going to say I've got 2 squared plus 1, so it's 4 plus 1, which is 5. Now that actually holds for the statement. So at this stage, if I were to take just a single example, x equals 2, plug it in there, and consider no other examples, I would say fine, statement is true, holds for everything. However, if I were to then look at any odd number, let's say x is equal to 1. If I were to plug x is equal to 1 in there, I'd have 1 squared plus 1. Now 1 squared we know is 1, so that would then give me 1 plus 1, which is 2. So what I've done is I've given you a single example that this conjecture and this statement does not hold for. Because of this, I'm able to openly and accurately say, therefore, the statement is false. Doesn't hold for every value of x, job done. So this there, counterexample. All we need to do, find a single example, conjecture doesn't hold, conjecture's false. And it doesn't matter the format of the conjecture, the only thing we have to make sure is if it limits it to a set of values for x, so for example, integer values or positive numbers, we stick within that range. Now here's a second example for you. If I say to you for any real number a, b, c and d, it's conjectured that if a is less than b and c is less than d, then ac is less than bd. The question is, can I find a counterexample to disprove this conjecture? Now remember, all we're after is a single example for this. This type of conjecture here, it might be useful to start thinking of relationships between positive and negative numbers. Now the kind of things you need to think about are negative times a negative gives you a positive. Negative times a positive gives you a negative number, because that could come into play and that could help us. Let's imagine what I'm going to do is I'm going to pick 4 values for A, B, C, and D, and I'm going to try and make it so that this counterexample proves that's false. Well, what I'm going to do is if I choose A is equal to negative 1, if I choose B is equal to 0, C is equal to negative 2, and D is equal to 1. Let's pick those 4 values for them. Now, this holds for the 2 conditions initially, because here, A is less than B, so that's satisfied. C is also less than D. That's satisfied. Now remember, I can pick any real number. So negative values are on the table, zeros are on the table, positive values are on the table. If I then look at the second part of the conjecture here, AC being less than BD, if I do AC, what I'm going to get is negative 1 times negative 2, which is 2. If I then look at BD, what I'm going to get is 0 times 1, which is 0. So in this case, if I pick these 4 values here, what I actually get is that AC is greater than BD. So AC is greater than BD. This disproves the conjecture because it's a counterexample. Therefore, my conjecture is false. I've got a single example there that I've used. It's false. Now, you can use any example there. I've picked those 4 values because I know they work and they disprove the conjecture. You can pick any 4 values you want that disprove the conjecture. So for example, I could have had a negative A and a negative C, and I could have had a positive B and a negative D. So the 2 negatives would give me a positive. I'd have a negative times a positive, which would give me a negative. So it could hold out for that condition as well. I could look at the size of the numbers. How can I make it so the size of the numbers are there? I could look at fractions and I could bring them into play and use fractions as part of my calculation. There is no limit when it's on real numbers. So because of that, there's a huge amount of examples. I don't have to use them all. I just need a single example. What I'm going to do is I'm going to show you one final example here. Now the conjecture for this one is that for any real number A and B, it's conjectured that A over B is always less than 1, and what that implies is that A has to be less than B. So what I want to do is I want to find a counterexample to disprove this conjecture. Now, again, this is one where we might start to consider negative numbers and looking at where they lie on a number line and look at a condition that comes with that. Now, if I were to pick a positive and a negative value here, let's say I set A to be equal to 1 and B to be equal to negative 2. So we take those 2 values there. If I were to then look at A over B, that would be the equivalent of 1 over negative 2, so negative a half, and that satisfies the condition of it being less than 1. That satisfies the first part of our conjecture. Now the second part states that because of this, A has to be less than B. However, if you look at the 2 values that we've got here, A is greater than B. Remember, we're looking at the full number itself, including the signs. We're not talking about the size of the number here. We're talking about the actual number. So for this example, A over B is less than 1, satisfies the first part, but it does not satisfy the second part of our conjecture. A has to be less than B. So quite simply put, it's a false conjecture. Again, single example that we've used to prove this. Bear this in mind when you're working with counterexamples. All we have to do is find one single example that works, that disproves the conjecture. If we can do that, then we've done our work. We don't have to use them all because there could be an infinite number that work. Single example is all you need.